next lesson is classifying numbers in your number sense unit. So the first thing we're going to do is determine if something is rational or irrational. So I'm going to go ahead and start with irrational. Irrational numbers are numbers that go on and on forever, which means that they are non-terminating. There is no pattern, no repeating pattern. So they are decimals that go on and on and on forever with no repeating pattern. The most famous irrational number is pi. So pi is famous because it's 3.14, blah, 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 blah. It goes on and on forever. There's no pattern. There's no repeat whatsoever. So anytime you see pi, it is irrational. I could even add it with a nice number. 2 with pi, still irrational. It's kind of like pi is a crazy number and you put it with a normal number. Well, just because you're putting it with a normal number doesn't make it all normal. It makes it actually all crazy. There we go, marker's dying. We talked about a dun dun dun. So if I have a 4.23, the dots that go with it, dun dun dun, make it irrational because I have no idea what's going next or what is happening next. It could be a decimal that is 232323, but I'm not sure. It could be a 28973. I have no idea. So that's number 2. Number 3 are any square roots that are not perfect squares. So if we remember our list that we did of perfect squares, the square root of 18 is not a perfect square. There's no number times itself that will give you an 18. It's not 9. Be careful, because 9 times itself is actually an 81. We're not doing a divide by 2. That's not the same concept. So all non-perfect squares are going to be irrational. On the other hand, rational. Anything that makes sense is rational. Rational numbers. We like rational numbers. They end, which means they terminate. They could be decimals. All fractions are going to be rational. Anything with a pattern is going to be rational. All right, so I can have a 2.7, that's rational because it ends. I could have an 8/9, that's rational because it's a fraction. I could have a 5.13 with a repeat bar because that creates or has a pattern. Or I could just have a really nice number, like a 0. A 0 ends, so it's rational. Now, rational numbers can be broken up into an even smaller group. So we have rational numbers, and then under that, we have what they call integers. Integers are numbers on your number line. So they can be positive or negative numbers that end, terminating numbers. No decimals. People like calling them positive and negative whole numbers, but whole numbers are a different type of number, which is going to be next. I don't want to call them positive and negative numbers I'm going to write with no decimals. All right, so your next type is going to be whole number. A whole number are zeros and positives with no decimals. Zeros and positive with no decimals. And then the last type of number is going to be what they call a natural number. Natural numbers are just your positive numbers with no decimals. So I am going to present you with an example, and we're going to see where it falls on the category here. Is it going to be, our first question is it going to be rational or irrational? And if it's rational, I'm going to see how far down this list I can go before it stops. All right, so my first question. Question number 1. I'm going to say the number 3. Now, is the number 3 a crazy number, irrational, that goes on and on forever with no repeats or patterns? No. A 3 is a number that ends. So it is a rational number. I'm going to put a big R here to say that it's rational. Now let's see if we can go further down the list. Is it on the number line? Yeah, it's on the number line. I could put 3 on the number line. So therefore it is an integer. So I'm going to put an I here. Is it a whole number? Meaning, is it positive or 0 with no decimals? Yeah, a 3 is a positive. So it's a whole number. And last but not least, natural number. Natural numbers are also known as counting numbers. When you play hide and seek, you start at 1. So this is a positive with no decimal. Yes, that is correct. This is a natural number. All right, example 2. I'm going to say the square root of 5. Well, let's think about our perfect square. Square root of 5, I know that the square root of 1 is 1 times 1. The square root of 4 is 2 times 2. The square root of 9 is 3 times 3. The square root of 5 fits somewhere in between 4 and 9. That's supposed to be a 4. Which means it's not perfect. It's a decimal that goes on and on and on and on forever. The only ones that end and are perfect are the ones where you could do a whole number times itself will give you what's inside your square root. So this is a decimal that goes on and on forever. Which means no patterns. It's irrational. All non-perfect squares are automatically irrational. This is irrational. As soon as you're irrational, you're done. You can't be irrational and then an integer. These only work for rational numbers, these subcategories. As soon as you're irrational, you are done with the problem. And the last one I want to go over, number 3, I'm going to say a negative 4.75. 4.75. So this is a decimal that ends. So it's not rational. Irrational, sorry. Because irrational means that they go on and on forever. This decimal I gave you, negative 4.75, does not go on and on forever. It's a decimal that ends. So it's rational. I'm going to put a big R next to 4.75, negative 4.75. It's rational. Now let's see if it's an integer. Can I put negative 4.75 on a number line? And the answer is no. You can put a negative 4 on a number line, but you can't put any decimals on a number line. So it's not an integer. As soon as you say no, do not go further down the list. As soon as one category, because you have to go in this order that I wrote on this paper, you have to go from rational to integer to whole number to natural number. As soon as you say you're done, you can't skip. You can't go from rational to whole number without being an integer. So as soon as I say no, I'm not something, you are done with your list. This is just a rational number. It's not an integer, which means it cannot be a whole number, and therefore it cannot be a natural number. All right, I actually wanted to do one more. Let's go to number 4. I'm going to say 0. The number 0. So 0 ends. It's a normal number, so it's not irrational. Irrational are numbers that are out of control, okay? So it is a rational number. We're going to put an R here. Irrational, good job. Now, can I put a 0 on a number line? Absolutely. 0 is usually in the middle of our number line, so it is an integer. So we're good with integer. Let's go to whole number. Whole numbers are zeros or positives. Is 0 a 0 or positive? Absolutely, 0, 0. So we're going to put whole number there. That's a W. And let's see if we can get this final category. Natural number. Natural numbers are positive numbers. Is 0 a positive number? No, it's not. 0 is not a positive number. So that's the only difference between a whole number and a natural number, is that whole numbers include 0, natural numbers do not. So we are done with this. A 0 is a rational integer and a whole number. All right, so that is the lesson for classifying numbers in your number sense category.